Right, we are going to be looking at these things we've already done in trig version, okay? We're now just going to be doing a hyperbolic version of them. So we want to know how to integrate these kinds of things that we have that look like this, okay? We already know how to do it because the formula book tells us how to do it. We already know the substitution that we use for these things because we talked about it when we did the substitution, didn't we? So when they talk about when they're saying about what's the sensible substitution and why would we use it, well, we could, for this one, use a squared plus a squared sine squared u. We can use the x as a sine u, and that's because 1 plus sine squared is cosh squared, and because you square root it, you get a cosh, and the derivative of sine is cosh, so you'll get the cosh bits cancelling out with each other, okay? So that's why we use the substitution. But does anybody remember what we said was the shortcut way to find out what substitution you should use if it's a show that? Look at the formula book. So when you look at the formula book, if they try and say, find out what this thing, show that this integrates to this, well, we know that the substitution is going to have to be to do with cosh, okay? But originally when mathematicians did this, they had to figure out which one they wanted to use. The only bit that it's saying in here, which you can read through later, is that you could use tan for this because of 1 plus tan squared being equal to sec squared, but the derivatives of this doesn't actually then cancel out in the same way that you want it to do, so it just becomes a little bit more complicated to use that substitution. So we always use the one that the formula book guides us into using. So this one, the substitution that we're going to use, is that x is what? A cosh u, because it's going to an r cosh, so we know we're going to be using a cosh within our answer that we've got here, and we just need to kind of figure out all of the things that we want. So we need a dx du, which is a sine u, and we also know that the square root of x squared minus a squared, well, x squared minus a squared is a squared cosh squared u minus a squared. What's a squared cosh squared u minus a squared? Cos squared minus 1, which is sine squared u. So x squared minus a squared is that. So the square root of x squared minus a squared is just a sine u. Okay? Yeah. So when we go in with doing all of the substitution, the integral of 1 over the square root of x squared minus a squared dx, we just go straight in with what all the substituting is. Well, we can see dx is a sine u du, and this is 1 over a sine u, and we're multiplying it by a sine u du. So luckily the a sine u's all cancel, and we just get the integral of 1 du, which is just u plus c. But we know that u is x over a r cosh. So it is r cosh x over a plus c. You'll notice I've done that really, really quickly. Why have I done it quickly? We've done it, but we've done it before, haven't we? We've done this before. It's a show that, yeah. But we also, if it's not to show that, we just use it. But we did this, but we did it with arc sine, arc cos, and arc tan. So it's the same thing. As long as you know your hyperbolic identities, and as long as you know that how you do a substitution. There's nothing at all that's new here. So if you haven't got that written down, you can write it down without even looking at what I've done. You know how to do it, okay? You don't need me to copy from it. Now we're just going to start using these things, and I've put a couple of things from the formula book, okay? These are in the formula book. These are also in the formula book, but they don't come up in the same area. They come up in the hyperbolic section. So there's a section in the formula book at the top of the page. It's on page 19. They've got a section here where they actually tell us what r sine x and r cosh x is in terms of ln. We did look at that. I remember we did it during rollover. I showed you a couple of lessons ago where that was. So we're going to integrate this. We're going to integrate between 5 and 8, 1 over x squared minus 16 dx. So which one is this going to be the same as? An r cosh, and in this case a squared is 16, so a is 4, so it's going to integrate to r cosh x over 4 between 5 and 8. Now this is the part where we want to use this fact that we've got here. Okay? So we get that it is the same as r cosh of x over 4 is, this is all in the formula book. Yep. So r cosh x is ln of x over 4 plus the square root of x over 4 squared, which is x squared over 16 minus 1 between 5 and 8. So when we sub in, we get ln of 8 over 4, which is 2, plus the square root of, what's 8 squared over 16? 64 over 16? 4. Minus the ln of, putting 5 in here, 5 over 4, plus the square root of 25 over 16 minus 1. So we've got the ln of 2 plus root 3 minus the ln of 5 over 4 plus 25 over 16 minus 1 is what?
5 over 4.
9 over 16.
9 over 16.
Yeah,
It's 9 over 16 this, and what's the square root of 9 over 16?
3 over 4, which is just 8 over 4, which is 2. Minus 11, 2.
And this is 2. Okay? So there's nothing new, just substitution and reminding ourselves that we have access to these things in the formula book. Okay?
Isn't there one for Rthan?
There is one for Rthan as well. Do you want me to add it in? So the one for, let's do it in a matching colour. Rthan x is a half ln 1 plus x over 1 minus x, and that only works when the size of x is less than 1. No, I didn't. No, it's definite. Trying to catch me out. It's definite integration. Ruhan, you tricked him. You double tricked him. You lured him in to say that. Yeah, obviously no constant because it's definite integration. All good?
I knew it. I was just like testing you, see if you would stop me, but no.
Do you write them down as we go?
Most of the time.
Okay, you can always go back and do them as well because you should be able to remember them.
I sometimes write, sometimes don't.
Cool.
Depends.
Harder example. Use a sensible substitution. Okay, well, anyone got a suggestion of a sensible substitution?
1/6 squared.
Did you say substitution of 1? What should we use as a substitution for x?
X is R shine.
Good. X is going to be r shine u. The clue comes from the question, the answer, right? The answer has got that. So, don't know why I wrote r shine u, not r shine u. No, shine u.
Oh yeah.
Because u will be r shine x, okay? We never do substitutions with r shine. We always be sine, cos, tan, r shine, cosh, tan, okay? So our substitution is going to be that x is shine u. So let's just quickly build this up. 1 plus x squared is 1 plus shine squared. And 1 plus shine squared is cosh squared. So root 1 plus x squared is cosh u. We also know, huh?
Why are you holding the normal pen?
In case I wanted to know. And so dx du is cosh u. So dx is cosh u du. So we're going to try and integrate. Tell me if I'm going too fast, but this is how fast we go at this point in year 13. So it's going to be 1 plus x squared is square rooted is cosh u. And we're multiplying by cosh u du, which is cosh squared u du,
Which is half shine u.
which
Half
is
shine u.
a half,
Why is there any plus?
because I haven't finished yet, I'm still integrating.
Yeah, but doesn't it just become a half shine u?
No,
It's integrated.
no, there's no reverse, you can't do reverse chain rule here, guys.
A half cost to you.
A half plus a half cosh
Shine.
2u.
Oh.
There's no shine with that.
One shine that you
Well, I'm pleased you said it. Trying to integrate that when there's a squared.
Yeah. Sorry.
Ah. So now it integrates to a half u. What does this integrate to?
a quarter
A
shine.
quarter shine to you. There we go.
Oh yeah, this is fun, this one.
That's it. And then subbing U's.
So when we sub in the u's, this is nice because we've got a half u, which is just u.
Why?
U is r shine x.
Yep, so that's what we've got.
So we get a half r shine x, but then we have this lovely bit to deal with here.
Reverse.
Can we just force it? So then we have a half.
Shine of 2r shine x.
Not fun, is it?
Can
It's
we-
not going
can
to
we
look like
force
that.
it into the answer.
We are going to have to just force it in a different kind of way. We're not going to look at
So we
this.
take out half.
Whoa, we're not all of us all at once. Luke?
We know that x is shine u.
Okay, so we're going to build. If we know that x is shine u, we are aiming to come up with, our aim is to say, that's the thing I'm interested in. I want to find shine 2u, because that's what I can't express here. Ruhan? Good, so this, we know, the thing that we're aiming for is 2 shine u cosh u. In fact, I might actually, I might do that in here. So it's going to be a quarter. Well, it's not going to be a quarter anymore because it's 2 shine u cosh u. So it's going to be a half shine u cosh u. Now I know what shine u is.
It's X. It's X.
Is that
We
Yeah,
rewritten
but what's cosh u?
Cosh you said is.
root 1 plus x squared? We wrote it.
Oh, have we written it?
Yeah, look, top left.
Oh. Oh, so I was making a big fuss about absolutely nothing there. So we've already got that written. Sorry. So we get a half r shine x plus a half x. Oh, you mean like force it like
Force
that?
it into that, yeah.
Yeah, sometimes when I don't know what you're saying, it's just hard to communicate. It's really hard to communicate it. So, and that's it.
Makes sense.
So if you ever get stuck with something and you're like, I can't make it go back into what it was, you're going to need to use some trig identities. Luckily, we know them off by heart, I hope.
Yeah.
Now, there's an exam question down on that second part, but I think we'll do the exam question as part of your homework.
Which example?
It's just literally on the next page on the booklet. The reason I'm going quite fast here is because I want to make sure that we can move on to differential equations soon. We also don't have a thing next week.
We have a Wednesday lesson and stuff. No, we don't. Oh, no, we don't.
We don't have a Wednesday lesson. So one of your homework questions is going to be to do this one. It's exactly the same as what we did in chapter 3 in methods in calculus, apart from the fact that it's going to be stuff with r shine and r cosh. You may need, for this thing that you've got down here, the ln bit, that's probably to do with this thing, okay? This one I will do as a class example, just so that we kind of finish off. I know it says your turn, but we might just kind of get started on what we think this should be. So it says here, using a hyperbolic substitution, evaluate this thing that we've got here. So which do you think might be a good substitution?
X equals cosh u.
Cosh?
Yeah,
No.
Yeah, it's Kosh.
Well, I would look in the formula book,
Oh, crap.
and it looks like an
Shine.
x
Yeah,
squared.
shiny.
Yeah, it's an x squared plus a squared. So we're going to use a shine substitution. So I'm going to instead,
I just look at it. I can't. I've got an even one.
but what shine u am I going to use? Good, 3 shine u.
A would be 3.
Because a is 3,
Because a squared is 9.
we know that the normal substitution we use is a shine u, but in this case it's 9 here. So we're going to go through the same kind of process. So our x squared plus 9 square rooted, do you think we can jump to that?
Yes.
So it's the square root
Cosh.
of 9 cosh squared u.
Which is 3 cosh u.
So it's 3 cosh u, okay?
Yeah.
What about dx du for this bit? 3 cosh u. And so dx is 3 cosh u du.
And what's x by itself is 27 shown.
And we're also going to, in a second, need to change what the limits are as well. So, if the x limits are 0 and 6, we get the u limits. So if x is 0, what is the value of u?
0.
And if x is 6, what's the value of u? R shine 2.
What are you doing?
What's happening?
Clean enough.
Come on, we've got 10 minutes left. I want to make sure we can do this. So we changed the limits. We're pretty much ready to do all of this, I think. So we are going to say between 0 and 6, x cubed over x squared plus 9 dx. Well, what's x cubed going to be?
27 shine cube.
All over. That thing we said was 3 cos u. We're multiplying it by dx, which is 3 cos u du. And the limits are now 0 and r shine 2.
3 cos u will cancel.
The 3 cos u's cancel. I'm going to take the 27. Shall I take it out?
Yeah.
Yeah.
Yep. So I'm integrating between 0 and r shine 2. Shine cubed u du.
Which is shine times shine squared. Which is shine times 1
Oh, let's go back to that.
Which is shine u times shine squared. And shine squared is
Cos squared minus 1.
cos squared minus 1.
And then you can fill that in through. Should I give the final product?
No, we're going to do it slow. So what's this integrating to?
Cos cubed
X minus cos x.
minus cos u.
Or cos u, yeah.
Between 0 and
R
r shine
sine 2.
2. Now we have to try and put r shine 2 into cos. Now, how are we going to put r shine 2?
Do we have to put the u back in first?
We're going to try and put the r shine into there. Now, how do we do that? What was that, Ruhan?
So I believe this should be r sine 2u.
No, why is it?
Well,
Not r shine 2, is that equal to u? So then,
you just put in u.
and then just change that then.
No, this is
Oh,
this.
no, yeah, so
This
you
isn't
put
what
the
u is
limit.
equal to. This is the value of u when x is that. So I can't remember. What do I do with r shine 2? I guess we know if we have r shine 2 and I want to put that in place of u, maybe I should convert it to ln. There's a better way of doing this though. Am I going to have to look at this? No, so we can use the fact here. This is the crazy bit. Okay, I've got it. So we know that shine u is 2, but we can't find out what shine u is by putting it in here. We need to find out what cos u is. So if you find out what cos u is, well, cos is the square root of, what connects cos and shine? Cos is equal to
90 minus x.
cos squared u minus shine squared u is equal to 1. So cos is 1 plus shine squared u,
Oh, okay.
which is 1 plus 2 squared,
Which is 1 plus 4.
which is 1 plus 4, which is root 5. So cosh u is 5 for this thing that we're going to do for the substitution that we have there. So what we can actually do is say every time we're trying to substitute in r shine 2 into here, we know that cosh u is root 5. Now that's hard. So I get a third times root 5 cubed minus root 5 minus, what's cosh of 0? 1 minus a third minus 1. So you get 27. What's root 5 cubed?
25.
No, root 5 times root 5 times root 5. So it's 5 root 5 over 3 minus root 5 minus 1/3 minus 1 is minus 2/3. So it becomes a plus 2/3 that we've got here. If we then multiply out by 27, you get 9 times 5, you get 45 root 5 minus 27 root 5 plus 18. 45 take away 27 is, why can't I do that? Is 18 root 5 plus 18, which is 18 root 5 plus 1.
Mad.
So the bit that we got stuck with was trying to do the r shine going into cosh, but we knew from over here, if shine u was 2, we could work out what cosh u was to be able to do that substitution. Very, very difficult question. Very, very, very difficult question.